Alright, so here's our position versus time graph. Shaped like this. And so one of the things I'm going to ask you to do, anytime you have a graph with lines on it actually, what do you think I'm going to ask you to do? Find the slope. So anytime there's going to be lines on a graph, I am going to ask you to find the slope. And we'll use that to help us analyze that. So let's go ahead and do that. Let's find the slope. It's too big, isn't it? Let's find the slope for each segment. So we're going to go ahead and find the slope for each segment. And by segment, I mean each kind of time segment here. So for example, you could do it every second, like 0 to 1, 1 to 2, and so forth. But you don't have to do that. You can just do when the slope is constant. So we could go from 0 to 2, 2 to 3, 3 to 4, and 4 to 5. So we really, if you look at our picture, we have 4 different slopes here. Alright, and how do we find a slope? Rise over run. Okay, so the generic thing, we say rise over run, right? Or delta y over delta x. That's our slope. So let's go ahead and do it for this one. So we have delta y over delta x. So our delta y here is 30. So we're going to go ahead and go 30 meters minus 30 meters minus 0 divided by 2 minus 0 seconds, and we get 15, right? And what are the units here? Meters per second. So what can we learn about a position versus time graph? The slope tells us what? The velocity. Yeah, so our slope here is going to be equal to our velocity. Alright, so 15 meters per second. And really you can see that from the graph. Every second we're speeding up by 15, or not speeding up, every second we're traveling 15 meters. So 1 second we're at 15 meters, 2 seconds we're at 30 meters. Alright? Okay, what about 2 to 3? So notice at 2 we're at 30, and at 3 we're at 30. Right? So when we do our slope, what do we get? 0. 30 minus 30. 3 minus 2 gives us 0, right? 0 meters per second. So what's happening there? There's no movement at all, right? What have we done? Stopped. Okay, so at that point in time, we have stopped, right? So we're at 0 meters per second here. By the way, it's a good idea to take a look at your graph. And you know, we generically say slope is delta y over delta x. But in this case, we have meaning of delta y. What is our y-axis? Position or distance, right? So I could write that, instead of delta y, generic, we'll write it as delta d. And what is our x-axis? Time. So instead of writing delta x, what could I write? Time, or delta t. And what is delta d over t? Velocity. Yeah, so delta d over t is velocity. So we can use that to help guide us when we're looking for meaning of slopes. Alright, let's keep going. Actually, why don't you keep going? You guys should be able to do the rest on your own. Go ahead and write those out. Calculate those slopes. Remember, you always do final minus initial when you do your subtracting, when you do your deltas. Okay, and if you could, can you write the physical meaning of these? So for example, 0, we said the physical meaning was we were stopped. What's the physical meaning of 15, negative 10, and negative 20? Go ahead and just write it on your paper, and then we'll discuss. So what's the physical meaning of the 15? We're moving forward. Then we stop. Then what do we do? Now we're going backward. Good. So in this case, we're going backward. Forward here. We're now moving backward. What about negative 20? We're also backward. Now what's the difference between the 20 and the 10 and the 20? Faster, right? So we're both going backward in both, but this one is faster. Right? So the last thing I did want to discuss on this is, what is the meaning of the steepness of the slope? Okay? Yeah, how fast it is. So in other words, a steep slope means what? Steep slope means, well, fast, okay, or faster. The steeper the slope is, the faster it is. In fact, if you have a slope that's horizontal, how fast are you going? You're not going, right? You're stopped. So you can see here we're at 30 meters, and here we're also at 30 meters. Okay?